So, good afternoon to one and all. Is the screen visible? Just check it once. Anyone you reply?
Yes, sir, visible.
Okay. So, in the morning class, we have discussed about the that ramp type, integration type, dual slope integration type, digital voltmeters we have discussed. So another two types of voltmeters are remained. So those two types we are going to discuss now here. Okay, so that is the fourth one is successive approximation type digital voltmeter. That is successive approximation type digital voltmeter we are going to call. I will give one example, best example I will give. So here what I will do, I will give one box of here now. I will give one box which is filled with sweet box I am going to give here. Okay, so somewhere here it is sweet or whatever it may be. I want to ask about what is the weight of this one here. How we are going to measure the weight? Can anyone tell? Now don't use the digital technology. Previous one we are going to call that. Previous ऐसा हाथ में पकड़ के बैलेंस करते थे ना, मालूम है? In the vegetable market, you consider that one. Anyone, if you have visited kirana shop, vegetable market, and all the things, so you can observe that one. They are going to add something, remove that one. If ज़्यादा हो गए तो थोड़ा निकलते, कम हो गए तो थोड़ा डालते. Yes or no?
Yes, sir.
So like that, how you are going to measure this one weight? So previously like this, they were using the weighing machine like this. Okay, so like this it was there. Yes, correct है ना, ऐसा ही रहते ना. So this is the weighing machine here. I'll put something here now. So ये जितना weight है उसको check करने के लिए हमने क्या करते हैं, पहला वो some amount of weight will add here. Okay, उसका एक stone रहते हैं, that stone I will add that one. Suppose ये down हो गए तब ये up हो गए, on that time क्या करते हैं, वो बड़ा वाला निकल के छोटा वाला डाल देते हैं इधर. Yes. So like this, by adding some removing, we are going to balance that one here. We are going to balance this one and this one. We are going to balance that one here. Now it is nothing but approximation. We are doing that one here now. Approximation. We are going to do that one here now. So for same method, we are going to use in this one successive approximation type digital voltmeter here. Now, in the form of digital, we are going to consider whatever the analog meter is there here, analog to digital converter. It is going to add. It is going to remove. Like that it is going to do that one. समझ में आ रहा है? थोड़ा adding, removing like that, whatever the old principle is there, based on that one only, it is going to operate here now. Okay, we'll discuss that one, how it is going to operate here. The successive approximations principle can be easily understood using a simple example, the determination of the weight of an object. Any object you consider, and I want to know the weight of that one. Nowadays digital weighing machine meters are there. When I will put that one, it is going to show that value here. How many gram is there, that means it is going to show that one. But previously it was not there. So that by considering that one, they have mentioned in the book here. By using the balance and placing the object on one side and approximation weight on the other side here. I will consider, I will put the weight on that one here. I will put something here now. Another side, I will put the weight stones I am going to put here now. If the weight is placed is more than the unknown weight here now, this is the unknown weight. This one is more than that one. So what I will do, I will remove something. I will remove some stone and I will add some lesser value over there. So like that, the weight is removed and another weight of smaller value is added over there. Another value of smaller value is placed and again the measurement is performed here now. So if the unknown value of the weight is lesser than the known value, on that condition, the known value, what I am going to do, that one, some weight I will remove that one, and lesser value I am going to add to make the approximations over there. To make the approximations here. Now, it is found that the weight placed is less than that of object. Another weight of smaller value is added here. Suppose it is downside here now. The unknown weight is greater than this one here now. So some less value I will add here. Some less value I am going to add over there. Okay. So abhi now also. So we will go to visit a kirana shop को जाते हैं अभी तो आपको 1 kg शक्कर चाहिए, 1 kg sugar you want to purchase that one. The person who is working in a kirana shop, what I will do, he will take one carry bag and he will go to the sugar that bag and he will put something and he will put on the weighing machine. When he will put on the weighing machine, it will not show exactly the 1000 grams over there. Exactly 1000 grams देखते क्या वो? It will not show exactly 1 kg. It may be lesser or it may be more. What he will do, he will add something lesser means. If it is more, he will take something. Yes or no? थोड़ा add करते, थोड़ा remove करते. Then approximately he will 1001 or 1002 or 9900, 999 like that. He will. It is approximately he will give consider that one as 1 kg. Yes or no?
Yes, sir.
So that method we are using in this successive approximation type digital voltmeter. We are going to use that method in this digital voltmeter. If it is found to be greater than the unknown weight of the added weight, then added weight is going to remove here. Now another small weight we are going to add. So in this manner, by adding some value and removing the value, we are going to do that one approximate weight we are going to do. For that reason, the name of this digital voltmeter came as successive approximation type. So successive approximation digital voltmeter, we are going to tell that one here. So this is the principle of this successive approximation type here. Just the principle of operation is this one here now. So we'll go for the actual diagram. We will go that one. See, this is the block diagram of this successive approximation type digital voltmeter here now. See, this is the main gate we are using here, main gate, and the start and stop pulse is given by this one, and the multi vibrator we are going to use for the reset. The ring counter, that is called clock counter, we are going to consider. Here the control register is there, that is called successive approximation register control here. Successive approximation register we are going to call, that is called SAR we are going to consider here. So this is, it is going to give the digital output here. We are taking some reference supply for the digital reference weight. Weight kitna hona chahiye pahla, wo reference we are taking here now, and we are taking input here now, another side. So we have kept one comparator here now. This comparator, what it is going to observe, it is the input is greater than the reference, it is going to observe that one here. If input is greater than the reference or not, V in we are considering as a reference, V out we are considering as the, so this is the control output we are going to consider. So input is greater than the V out, the reference value. On that condition, what will happen? This output, it is going to show that one as 1, and it is going to give here the register value. Again, it is going to send here. It is going to set V here some values. It is going to set. See here, 8 clock pulses we are going to operate here now. D0 to D7 here now. That is nothing but from 0, 0, 0, 0 here now, like this. So again 0, 0, 0, 0 here at initial condition here. D0, D1, MSB, this one we are going to call it as most significant bit. MSB, that is called most significant bit, and this one we are going to consider as LSB, that is called least significant bit, we are going to call that one. So at the condition, initial condition, what will happen? If V input is greater than V output, the comparator it is going to give the output. Based on that, the start and stop pulse will be generated here now, and it is going to give the output. So again, we are going to control circuit, it is going to compare with that one. So same it is going to do here now. So if it is this V, there are only two conditions are there. V input is greater than V out. So what is the difference? We have to observe that one here. No, it is greater means it is V output से double है क्या? V output nearer है क्या? So approximation we have to bring that one. It should be V input is greater than equal to V output. We have to bring that. Or less than equal to V output. That one we have to make the approximation here. No, based on that it is going to operate here. How the bits are going to set and reset here. If we are D0, D0, D1, D2, D3, D4, D5, D6, D7. Here 8 bits we are using here. So each bit, if it is 1 is there, then we are going to call as set. If the output of that one will be 0, then we can call that one as reset here now. That is 1 means set, 0 means that is it is going to reset that one here. First what we will do, we will consider this one as D7 as 1, D6 0, D5 0, D4 0, 3, all the 0 we are going to consider that one here. Okay, so immediately what it will take, whatever the input voltage is there, that half of that one we are giving here now. Then also what will happen, the input is greater than output here. No, here also the input is greater than V out is there here. No, it is not sufficient, it has not reached over there. Then again what we have to do, some this one whatever reset is there, it one we can change that one into set here. Next we have to check that one V input, we have to compare that one. Next again if it is there, then we can consider that one. Suppose for after setting this one, if V output equal to V in is less than V output, less than हो गया सोचो अभी. Okay, if it is V input is less than V output, on that condition we have to reset this one again and we have to set this one. We have to set. So now we have to check that one. Like that, by setting, resetting this all the bits, we have to check the approximation method of this comparator output. We have to check that. For that reason, successive approximation we are going to call that. So no need to detail explanation of that one here. No. So I will go for the table directly. So same diagram you can use in the table here. No, all the explanation is there. Is this visible? Table is visible. Yes.
Yes, sir.
See, listen carefully here. Here the important is there. The initial condition what I will do, I am setting this D7 I have set it here now. I will compare with the unknown voltage here now. So that is input voltage I have compared. So what will happen? I will set this one means the input voltage is less than the output voltage ho jayega. Okay, input voltage is less than output ho jayega. So our aim is to how to bring nearer value. So if V input is less than V output, so हमने क्या किए, 1 किलो साकर के लिए हमने 2 किलो का स्टोन रखा है, ज्यादा हो गया ना. 1 किलो साकर के लिए हमने 2 किलो का रेटेड वैल्यू 2 किलो रखा है. That is not good. What we have to do, we have to reset that one. We have to take this one back and another one we have to add. For that reason what we have to do, here D7 set है, उसके लिए 1 हो गए. Next step what we have to do, we have to reset the D7 here. Whatever this 0 is there, we have to make that one as 0 and next we have to set the D6 here. D7 को next point में क्या करता हूँ, D7 को reset करता हूँ और D6 वाला को थोड़ा इससे कम value I am going to use that one. So less than D7 value I am going to set that one here. D7 is reset, so that is called 0 is there and D6 is set here. No, next all other things we are going to keep 0 here. No, I will compare that one. Still it is in the same condition only. V input is less than V output. Again what I will do, I will reset the D6 value here. Now this one is there, that one I will reset, so it will become 0 and other things are same as it is. But D6 का पहले कौन सा है, D5 value, small value is there, so that one I am going to set here. This bigger value I will remove, I will add the small value here. So D5 is set now here. Now so I will compare that once here. V input is greater than V output here, so it is set here. So I will set that one. वो stone है ना, that one I am going to fix that one over there. So this is fixed one, it is set only. Still what we have to do, we have to bring the nearer value. Again what I will do, by keeping this D5 as a set only, I will keep this one as set as 1 only. Next I will set the D4 as 1 here. No, that is D4 also I will set as 1 here. again it is V input is greater than V output only. So still there is the unknown voltage is greater than in output voltage here or reference voltage. So again I will D4 I will set that one. I will set. Next क्या करता हूँ, इसको 1 करता हूँ D3 को. I will check that one. See here, इसको rated voltage is greater than the input voltage. So on that condition I will reset this one into 0 and next value I will set that one, that is 1 here. So other things we are going to keep this one as 1 as it is here now. So we'll go for checking from D7 to higher values to lower we are going to checking here. So we'll set the D2 value here now. Again you will check that one, it is V input is less than V output. So what I will do, it is not correct, then again I will reset that one. Next उससे छोटा value लेता हूँ थोड़ा, वो check करता हूँ इसको match हो रहे, then it is okay. D1 is set here now. Next will by keeping D5, D4 and D1 set put के, next I have to check that one. D0 I will set that one here now. So this one approximately it is going to give the same value, that is called the output is 1 here now. Whatever the input voltage we are going to consider as 1 volt we are using here now. So to bring the 1 volt we have taken the approximation method we have considered, that is 0.99785 is equal to 1 only. 0.99785 approximately it is equal to 1 or not? Yes or no? आपका आवाज ही नहीं आ रहा है.
Yes, sir.
Very simple method. I have 1 kg stone, I have half kg, पाव kg, 250 gram, 100 gram stone रहते हैं ना, उसको एक बड़ा वाला रिमूव करने का, ऐड करने का. रिमूव इज नथिंग बट रीसेट, ऐड इज नथिंग बट सेट. समझ में? Same method we are going to bring that one here now. Same method we are using here now. हमारे पास इधर कितना है, पहला 2.5 वोल्ट का हमने ऐड किए, उसके बाद 1.5 का ऐड, 1.25 का ऐड किए, 0.625 का ऐड किए. Like that we are going to approximation method we are going to do here and we are going to measure the value here. So this is the simple concept and how this the successive approximation register is going to operate here. Now it is going to operate for 8 bits. So higher value से चालू करते, पहले ये ऐड करके देखने का, ज्यादा हो जाएगा, इसको 2.5 वैल्यू हो गए. नेक्स्ट उससे कम करते हमने, उसको ये सेट करके उसको क्या किए 1.25 ऐड किए, वो भी ज्यादा दिख रहे, उसको क्या करेंगे फिर 0.65 ऐड किए, 0.65 क्या हो गए, बहुत कम हो गए, इसको बहुत कम हो गए. सो ऐसा ही उसको ऐड करने के लिए और एक थोड़ा ऐड किए और थोड़ा स्टोन्स ऐड किए इधर, और some voltage we have added here now, that is called next D4 को सेट किए ऐड करने के बाद, इसको 0.9375 हो गए, थोड़ा इंक्रीज हो गए. ओके, देन अगेन और थोड़ा कम पड़ गए, नेक्स्ट उसको आई विल ऐड दिस वन, बट इस टाइम इट इज गोइंग टू ज्यादा हो गए. सो इसको क्या करता हूँ, उसको 0 ही वापस रखता हूँ और उससे छोटा स्टोन आई विल ऐड दैट वन. सो विल चेक दैट वन, वो भी ज्यादा हो गए, फिर उससे छोटा ऐड करेंगे. सो नाउ इट इज सेम 0.97725 आ गए. सो और थोड़ा चेक करना है, इसको लास्ट वैल्यू चेक किए, दैट इज कॉल्ड 0.99785 आ गए. सो इट इज अप्रोक्सीमेटली 1. सो बोथ आर मैचिंग एंड अप्रोक्सीमेशन मेथड वी हैव डन हियर. Any doubts you can ask. If you have any doubts you can ask me. Any doubts? Hello, I'm asking to you peoples only. समझ में आया क्या?
Yes, sir.
Okay, so the next one we are going to do that continuous balance digital voltmeter. What it is going to do, it is not approximation, it is continuously it is going to balance that one actually. Also this one we are going to consider for the DC method we are going to use. So DC to DC converter actually, that is called chopper, we are going to call that one, chopper circuit we are going to call. So this is the mechanical chopper we are going to use. So one side it has 2 connections are there. One side we have connected the input supply, another side it is connecting, taking from the precision potentiometer, it is taking that. Potentiometer क्या करते हैं इसको, variable, it is going to adjust the output here now, it is going to adjust the value and it is going to give here now. So And for the chopper, the extra supply is given, that is AC drive supply to drive the chopper circuit here now. So that one directly it has taken from the external supply here now. So this chopper circuit, it has two inputs. One is the DC input it has taken here now. So that is, we are going to use attenuator, which is the signal is high, then it is going to attenuate. If the signal is low, then it is going to amplify that one. That is called amplifier, we are going to call. And you'll check that one, overload protection and AC rejection. If any AC content is there, it is going to reject that one. Then it is going to give the chopper to the input here. From another precision potentiometer, it is going to give that one. So next what you will do, the pre-amplifier, it is going to compare this chopper circuit, it is going to compare that whatever the input and precision value here now. So that one, the supply, it is going to apply it to the power amplifier. This power amplifier, what it is going to give, this supply it is going to give to the servo motor here now. Whatever the difference is there, based on that, the difference, the servo motor is rotates and it is going to give the reading here now. So if you have a vehicle, two wheelers are there, आपका speedometer के बाद kilometer run हो जाते, मालूम है क्या? Like a wheel, it is rotating, then it is going to show that turn, it is going to move that one. Yes or no? किलोमीटर के ये रोटेशन हो जाते, रीडिंग देखिए, like that the servometer, it is going to rotate, and how much it is going to rotate, whatever the difference is there here now, that much it is difference, it is going to rotate and it is going to read out the value here. So continuous balance, it is continuously, it is going to give that one. If whatever the difference is there, what it will do, the precision potentiometer, it is going to adjust here now, and it will make the balance here. It will make the balance and it will make as the servo motor, it is not, should not do display the value over there. So that is nothing but whatever the input voltage is there, that is called output, that is the reference voltage here now. So if there is no difference at all, means either how much reference voltage you have considered, that is nothing but same as the input only. So that is, the input voltage is proportional to the reference voltage, you can tell that. So for that reason only, continuous balance digital voltmeter, it is, we are going to call this one here. This is called continuous balance digital voltmeter here. We'll discuss with this explanation here. Continuous balance digital voltmeter, the basic block diagram is shown here now. The input voltage is applied to one side of mechanical chopper here. The mechanical chopper we have used here now. So that is input side, one side we have connected the input side, and the other side being connected to the variable arm of precision potentiometer here. This is the variable arm, that is potentiometer we have used here. The output of the chopper comparator, which is driven by the line voltage here now. This mechanical chopper means it is going to driven part here now. So it is going to drive based on taking the supply here now, external supply here now. So output of the chopper comparator, which is driven by the line voltage at the line frequency rate here now. That is how much, 50 Hertz frequency here now, is a square wave signal whose amplitude is function of the difference in voltage here. So it is a square wave, it is going to operate that one. So whatever the operation is there, that is difference between this and this here. Based on that, it is going to operate here now. The amplitude is the function of difference in voltages connected and the opposite side of the chopper here. Here how much voltage is connected, here how much it is getting connected, whatever the difference is there, based on that the amplitude of this value is depends here. The square wave signal is amplified here now, it is amplified, then fed to the power amplifier here now. It is fed to the power amplifier. The amplitude square wave difference signal drives the arm of the potentiometer. This one, the arm of this potentiometer, which is dotted line, it is connected here now, it is going to rotate that one here now, potentiometer in the direction needed to make the difference voltage to zero. A difference voltage zero करने के लिए, in which direction it should have to rotate, it is going to adjust and it is going to set and it is going to take the reference supply according to that through a servo motor here now. The servo motor also drives a mechanical readout, which is an indication of the magnitude of the input voltage. This one, it is going to, how much difference is there, that much it is going to rotate and it is going to give the input voltage here now. So this digital voltmeter uses the principle of balancing here now. Principle of balancing also it is using here now. Instead of sampling here now, instead of sample, it is rotation balance it is going to take. So because of mechanical movement, the average reading time is 2 seconds here. Average reading time, how much it is going to take? That is 2 seconds. It is going to take that one. This is very simple method. Fifth one, continuous balance type. So it completes all 5 types of digital voltmeter. Can anyone tell all 5 types of digital voltmeter name? I'm not going to ask anything. Only I am asking the names of 5 digital voltmeters. In that one, fifth one I have already shown here. This is the fifth one. First 4. Anyone? Ramp type? Yes? Reply to this at least.
Yes.
Ramp type, integration type, dual slope integration type, successive approximation type, and continuous balance type. Okay, so these 5 types of digital voltmeters are there. Already have given the assignment. This is the major part of this unit. You practice it, you can remember the diagrams. Okay, this power pre-amplifier, what it is going to do, attenuator ka kaam kya hai. So that one, like that, you have to remember that one here. Okay, so we have discussed about digital voltmeters. We have discussed. So same like, what is the operation of digital multimeter here? So see here, for the measurement, actually digital instruments, we can use the DC voltmeters separately. Yes, DC voltmeters are there. AC voltmeters are there separate. That is AC voltmeters are there. So resistance meters are there. Ohm meters we are going to call ohm meters are there. Okay, ammeters are there again for the AC and DC separately here. AC and DC here. Now ammeters we are going to call that. Ammeters we are going to call here. That is called DC ammeters here. How many components are required here now? How many meters? 1, 2, 3, 4, 5 meters are required to measure the AC voltage, DC voltage, AC current, DC current, and resistance over there. But this multiple operation, to do this 5 operation in one instrument, we have made one instrument that is called digital multimeter. We have made here. We have made a digital multimeter here. Only multimeter we have used. Digital multimeter we have used here. It can measure AC voltage, it can measure DC voltage, it can measure the resistance, continuity, AC current, DC current, all the things. But we have provided a knob over there. Knob over there. So this is the knob we are going to call that one here. This is the knob here now, where we should have to, it should have to connect. It should have to connect AC, or it should have to connect DC, or it should have to connect resistance here. So we are going to use the knob here. Okay, see here the input we are going to give. The input is given here now. So it will comes input. You have to check that one, which one we are going to measure. Suppose AC voltage we are going to measure. So this knob, it should have to connect like this here. Should have to connect like this. So it is going to give the DC, sorry, not DC here now. This one directly it is going to connect to the AC. I will remove all the things. Just a minute. So directly it is going to connect to the AC here now. We have set the knob to the AC here. It is going to attenuate that one. So the signal is large means it is going to reduce that one, and it is going to attenuate that one. Next AC, it is going to convert into, so that is nothing but analog is converted, that is conversion sum. It is going to do some fluctuations are there and all the things. Again we have knob here now. Again we have knob here now. So we have to connect here now. That is analog to digital. We have to connect here. So this analog signal is converted into digital, and it will take the precision reference here now, and it is going to give the display value here. It's going to digital display. It is going to do here now. So if you want to interference, then interface that one. So interface you can do that one, and binary coded decimal output also we are going to get that one here. So the output digital display is there. Then binary coded decimal means that is called 0, 1, 0, 1, like that. We can get that one also by interfacing that one. The number 8421. मालूम है ना आपको? So that is 1, 2, sorry, 1010 is there. Then what we can write this one as 1 is 8, 2, that is called, we are going to consider, that is called 10 here, like that. Binary coded decimal. So we are going to call that one here. Okay. Like that, it is going to operate for AC. It is going to AC attenuators and it is going to connect to the analog to digital. If it is DC is there, then directly it is connecting here. No DC attenuator will be there. It is going to connect here directly and it's going to give the display. If it is resistance is there, instead of connecting these all the things directly, it is we have to fix the knob over there. Digital multimeter, I don't know how many of you send that one. We have to set the knob. कौन सा measure करना है, set करना है. So it is going to set here ohms and it is going to give the ohms converter. It is going to do converts and we are analog signal is converting to digital and the precision reference we have to consider and it is going to display. So voltage and current, all the things we can measure here now. Suppose we are going to use the measure the current over there. See here, voltage we have applied here now. So measure the current. So the precision reference, what it will do, it will give the reference resistance value. Already the voltage value is given to here, AC voltage. So from the precision reference, it will do that one V by R and it is going to give the current value here. It is going to give the current value. The resistance value is taken by a precision reference here. Okay, if we want to measure the resistance here now, on that condition, you can take the current reference as the here. It will provide VI and R reference here now. It is going to give all the reference value to give the output as per our requirement. By using a single meter, we can measure more than one parameters, electrical parameters. And we can consider that one multi-purpose meters. We are going to call that one. So that name came digital multimeter. We are going to call that. It's called digital multimeter. So same explanation they have written here in the explanation. That one. Okay, so this is the operation of digital multimeter here. Now it can measure this one as DC voltmeter, AC voltmeter. You can use as ohm meter for the measurement of resistance and all the things. So same whatever I have explained, I have written all the things here in this one. So I will draw one more equation or one more block in the for the simplified block I will take for the current measurement. See here, this is the current measurement we can consider. So here we have used one op-amp we have used here now, which resistance is very high here. This resistance is very high resistance we are going to use. If the resistance is high, what is the current flowing through that value, this my device? Resistance high is nothing but what is the current flowing through that device? Will be almost zero, no? Yes or no? Hello? आवाज आ रहा है क्या?
Yes.
Yes, sir.
It will be almost zero is there. So no current will flow at this op-amp here. Now what will happen? So the input current, whatever we have applied here now at the summation of this summation point. So that one, it is flow through the resistance here. We have three reference resistance they have given here now. 10 ohm, 100 ohm, 1 kilo ohm here. 10, 100, 1 kilo ohm. So almost whatever the input current is there, input current, all the current it will flow through the resistance, that is called reference current here now. So because of this one here high resistance, it will not flow here current, it will blocks over there. So based on this one, the current flowing through this resistance, it is going to create the voltage drop here now. Here IR is there, here resistance is there. We can measure that one here now, voltage drop across that one. So analog to digital conversion, we can do that one. And decade counter, it is going to count the pulses, it is going to count, and it is going to get the digital output we are going to get here. So the explanation is given. I will read this one. This is important is there for that reason. The current to be measured is applied to the summing junction. Since the current at the input of the amplifier is close to zero, input of the amplifier is close to zero because of very high input impedance of the amplifier or resistance here. So whatever the current is there, that is IR is very nearly equal to I naught. This IR is very nearly equal to the II, that is called input current here now. So the current IR causes a voltage drop which is proportional to the current here now to be developed across the resistance. It is going to causes the potential drop because we are using a resistance here now. So current, product of current and resistance, what it is nothing but it is a voltage drop only here now. Voltage drop it is going to produce which is proportional to the current here now. That is proportional to the current here now. So this voltage drop is the input to the analog to digital converter, thereby providing a reading that is proportional to the unknown current. It is going to give the unknown current which is proportional to the voltage drop here now. So the resistance is measured by passing a known current. Known current pass karne ka, we can measure the resistance. Voltage drop across that one, we can measure that one. So voltage known current is there. So R equal to V by I, we can measure that one. So we can, resistance can be measured by passing a known current over there. So the voltage drop across the resistor is applied to analog digital converter, thereby producing an indication of the value that is called unknown resistance here. Now we can measure the current here now, that is current to voltage converter. Here input is given current, but the output we are getting voltage, but that voltage is proportional to the input current, we are going to call that one. So this completes the digital multimeter, it is going to complete that one here. This completes the digital multimeter here. This is the digital multimeter diagram. Any doubts here? Any doubts? Hello, I am asking to you people only. कोई तो reply दिए at least? No sir, ठीक है. So one more topic we are going to discuss, that is called Q meter. We are going to discuss in the today class. Q meter is nothing but quality meter, we are going to call them. Q meter is nothing but quality meters. We have already in the bridges, while calculating the capacitance, unknown capacitance, we have Q factor, we have derived the formula. Yes, that is called Q factor, we have derived the formula. That is called the inductive reactance to the resistance, inductive capacitance to the, reactive capacitance to the resistance, that is called capacitive reactance, and inductive reactance we have discussed, that is called XL and XC. XL is nothing but inductive reactance and XC is nothing but capacitive reactance here now. So in its three-phase, not three-phase, in a series RLC circuit, it has both resistive component, inductive component, and capacitive components over there. It has both resistive, inductive, and capacitive components. And that condition, what we have to do, we have to get the quality of that circuit, we have to check that. Especially this matters when it is going to matters. What are the radio applications are there, application equipments are there, so materials or circuits are there, in that place it is going to happen. It is useful. We have to check that radio frequencies, voltage, whatever, what is that one? Q factor, we have to check that one. Quality factor, we have to check that one here. So have you heard the name of resonance? In a series RLC circuit, if XL equal to XC, the inductive reactance equal to capacitive reactance, that is called series resonance, we are going to call that. If it is in parallel circuit, that is called parallel circuit. If XL equal to XC, then that is called resonance, we are going to call here. Now at this condition, XL equal to XC, we have to find the frequency value, we have to find. Based on that frequency value, we can give the quality of the product or circuit over there. Can give the quality of the product or circuit, we can decide that one. So we'll discuss here. The overall efficiency of a coil and capacitors intended for radio frequency application is best evaluated using the Q value here. We can evaluate it by a Q meters here. So the Q meter is used to measure some electrical properties of the coil and capacitors here. That some inductive coils and some capacitors, based on these properties of the inductive coil and capacitor, we can measure the Q meter or Q value, that is quality value, we can measure that. So the Q meter working principle is based on the series resonance here. Based on the series resonance. So the voltage drop across the coil, that is called inductive reactance here now. Inductance, that is our capacitor, is Q times the applied voltage, where Q is the ratio of reactance, that is called X divided by R. It may be inductive reactance or it may be capacitive reactance. So the quality factor Q is the ratio of the reactance to the resistance we are going to consider. So the reactance, it may be inductive or it may be capacitive, we can consider here now. So what we will consider that one? If a fixed voltage is applied to the circuit, the voltmeter across the capacitor can be calibrated to read the Q directly here now. To read the quality value here now, we have capacitor can be used and the voltmeter across the capacitor, it can be calibrated here now. Okay. So I will show the circuit diagram and I will explain this one. We have considered one. See here, what something is there. The Q meter works on the series resonance. It is going to work. The resonance is the condition exists in the circuit when the inductance and capacitance reactance are of equal magnitude over there. Whatever I told that one, the resonance is nothing but the inductive reactance equal to capacitive reactance here now. So on that condition, we are going to the magnitude of this XL and XC are equal. Then that one we are going to consider as resonance here. They include energy which is oscillating between the electric and magnetic field here. This includes energy that is oscillating between electric and magnetic field of the capacitor and as well as inductor respectively. So the Q meter is based on the characteristics of resistance. The value of the Q meter, Q value, it is based on the characteristics of resistance, inductance, capacitance, and of the resonant circuit here now. We are considering the resonant circuit. So the characteristics of resistance is matter, the inductance and capacitance. All the characteristics are required to get the Q value here. So we are going to consider one circuit that is called series resonant circuit here now. Simple series RLC circuit we are going to consider here now. See here, we have connected given AC supply. One series resistance is connected, inductance is connected in series with resistance, and the capacitance is connected in series with resistance and inductance here. Okay, so this voltage drop across this resistance is ER we are going to consider. Voltage drop across this one is EL, and voltage drop across the capacitance, that is called EC, we are going to consider here. So what we are going to consider, if the inductive reactance, that is XL equal to XC, that one we are going to call as, that is resonance we are going to call it. So for that reason only, here voltage drop across this EC and voltage drop across capacitor is equal to voltage drop across resistance and inductance here now. EC equal to EC here. They have made here now. This is AC here. So if voltage drop across these two is same, then on that condition the resonance occurred over there. So this is the resonance circuit we are going to call that. So under resonance condition, at resonance condition, XL equal to XC, we already know that. What do you mean by XL? What is the formula for XL? XL equal to omega L. Can write omega L. Yes. XL equal to omega L. Omega is angular velocity. That is called 2 phi F. We are going to consider 2 phi F naught L here now. F naught is nothing but frequency, at a resonant frequency we are going to consider, and XC equal to 1 by omega C. XC equal to 1 by omega C here now. So 1 by 2 phi F C. We can write 1 by 2 phi F is F naught I will consider, that is F naught C here. So we'll consider some parameters here now. E is nothing but applied voltage. EC is nothing but voltage across capacitor. EL is nothing but voltage across the inductor. XL is nothing but inductive reactance. XC is nothing but capacitive reactance. R is nothing but coil resistance. I is the current flowing through this circuit. I is the current flowing through the circuit here. At resonance condition, that is XL equal to XC we have considered. So voltage drop across the inductance, that is called IXL we are going to consider. Voltage drop across the capacitance, we are going to consider that is IXC. Voltage drop across the resistance, that is called IR. V equal to IR, formula malum hai? Yes, that is according to Ohm's law. Same thing we are going to consider, that is IR equal to V, voltage drop across resistance, IXL, that is voltage drop across the inductive reactance, or inductance, and IXC is nothing but voltage across capacitor here. That one we have written here. So we know that the Q factor is, QL is the ratio of reactance to the resistance. So what we have to do, I will write that is XL by R, the reactances are, two reactances are there. XL by R equal to XC by R, you can write that one. Both the formulas are same here. Q equal to XL by R equal to XC by R. You can write both the formulas. So now you consider XL by R and XC by R, both I will consider here now. So here 1 by 2 equal to 1 by 2, both will cancel, 2 will get cancelled over there. So this R will R and R will get cancelled here. So XL equal to XC ho gaye. XL equal to omega L and XC equal to 1 by omega C here. Omega equal to 2 phi F naught. So XL equal to 2 phi F naught L I will write here now, and XC equal to 1 by 2 phi F 2 phi F naught C I will write here now. So what I will do now here now, so this one I will send into LHS side. Only F naught is there, I will send into LHS side. This denominator will send into LHS side. It will multiply over there and it will go to the numerator over there. So here F naught is there, F naught is there. It will become F naught square. We have written here. This 2 phi is there in the LHS side, the numerator. That one I will send into RHS side. It will become multiplier to the denominator. So 2 phi into 2 phi, that is called 4 phi square. 2 into 2, 4. Phi into phi square I will consider here now. And this L is there. Here C is there. LC we have considered here. So F naught square equal to 1 by 4 phi square LC we have found here now. So that is F naught square. If F naught equal to square root of 1 by 4 phi square LC here. Square root of 4, what is the answer? 2. So 2. Phi square, square root of phi square, that is called phi. So 2 phi square root of root LC here now. Root LC we are going to consider here. So F naught equal to 1 by 2 phi root LC. This is the frequency of the under resonance condition we have calculated here. So this is the simple expression of the Q meter expression for the frequency under resonance here. Now it completes the Q meter here now. So if you have any doubts, you can ask. Next, in the next class, we will discuss about electronic counter, energy meter, and LCD LED over there. And the 4 topics are there. So in one class, we can finish that one. In one class, we'll finish that one. If you have any doubts, you can ask me. Any doubts? Hello?
No, sir.
Okay. So give your attention. I will call the absent numbers only. Roll number 3 is absent. Roll number 7 is absent. 8, 9, 11, 15, 17, 19, 21, 25, 27, 29, 31, 34, 36, 37, 38. These many are absent. If anybody is there, you can tell your number. I'll put present. Yes. So nobody is there. So we'll stop here only and we'll continue the counter and energy meter, LED, LCD. We'll discuss in the next class. Okay.